Welcome to part 2 of the indefinite integrals and the net change theorem lesson. I have another example here, example 3, evaluating the definite integral from 0 to pi over 4 of 7 plus 9 times the cosine squared of theta divided by the cosine squared of theta d theta. So we could break this up. This will be the integral between 0 and pi over 4 of, this will be 7 divided by the cosine squared of theta plus 9 times the cosine squared of theta divided by the cosine squared of theta d theta. And this can be slightly simplified to be the integral from 0 to pi over 4 of 7 times the secant squared. This would be secant squared of theta plus 9 d theta. So evaluating this gives us 7 times the tangent of theta plus 9 theta. And we want to evaluate this between 0 and pi over 4. So this will be 7 times the tangent of pi over 4 plus 9 times pi over 4 minus 0 plus 0. This will give us 7 plus 9 times pi divided by 4. So this net change theorem, this is where the integral of a rate of change is the net change, the integral from a to b of capital F prime of x dx is equal to capital F of b minus capital F of a. So here's an example. A particle moves along a line so that its velocity at time t is v of t is equal to t squared minus t minus 6 measured in meters per second. And we want to find the displacement of this particle during the time period between 1 and 4 seconds. So this is just simply the integral between 1 and 4 of the velocity function t squared minus t minus 6 dt. So based on this, this would be a third times t cubed minus a half times t squared minus 6t. And this whole thing evaluated between the values of 1 and 4. So that will become 1/3 times 4 cubed minus a half times 4 squared minus 6 times 4 minus 1/3 times 1 cubed plus, this would be minus, excuse me, minus a half times 1 squared minus 6 times 1. So doing that whole thing out, we get negative 4.5 or negative 9/2. So this particle moved to the left. Four and a half meters. And the distance traveled during this time period. So we can observe that t squared minus t minus 6 factors to be t minus 3 times t plus 2. And we can see that this velocity is less than or equal to 0 over the closed interval from 1 to 3. and the velocity is greater than or equal to 0 in the closed interval from 3 to 4. So what does that mean? That comes into play with this. We want the integral from 1 to 4 of the absolute value of v of t dt. And we could break this up since we have a negative velocity versus a positive velocity. So let's do the negative first. This would be the integral from 1 to 3 of the negative v of t dt plus the integral from 3 to 4 of just v of t dt. So what does that mean? That means we want the integral from 1 to 3 of negative t squared plus t plus 6 dt plus the integral from 3 to 4 of t squared minus t minus 6 dt. So this would yield us negative 1/3 t cubed plus a half t squared plus 6t, evaluated between 1 and 3, plus a third t cubed minus a half t squared minus 6t, and this one between 3 and 4. So evaluating this gives us as a fraction 61/6, and as a decimal that rounds to be about 10.17 meters. That's that entire distance traveled during that time period. And then finally, example 5, the area of this region that lies to the right of the y-axis and to the left of the parabola, x is equal to 4y minus y squared, is given by the integral from 0 to 4 of 4y minus y squared dy. And we want the area of this blue region. So this would be the integral from 0 to 4 of 4y minus y squared dy. So this will be 2y squared minus a third y cubed. And that's a bad 3. Bear with me. Y cubed. And this is calculated between the values of 0 and 4. So 2 times 4 squared minus a third times 4 cubed. And this gives us, and then, if we put 0 in, we just get 0 back anyway. This will make 32/3. And as a decimal, that is about 10.66, with those 6s repeating, but ending it at a 7. Let me know if you have any questions or concerns. Thank you.